Okay, everybody, Assalamualaikum. Welcome back. We call it our main business as a civil engineer. We must give you a good
Waalaikumsalam.
training. A good training. So, one of the training that you must understand about the fundamental of surveying. Right? So, today we want to learn about how to make it curve. So, you can see from my slide, this is the curve. So it's not the IKEA curve at Damansara in Kuala Lumpur, but this one a theory of curve of highway or roads. So if you are come from this way, mean that from this one, of course you have the curve on your right. If you come from this point of curve, of course your curve on your left. This one is on your right curve. So this is we call it horizontal curve. Alright, next. So number one, we want to do what the lesson outcome after we finish this course. What we understand, what the meaning of the curve. Okay, number one, able to state and explain two different type of curve. So actually, when you see this one is we call it horizontal curve. This one is horizontal curve. And if you go to, we call it Cameron Highland. It's a Cameron Highland. You have, we call it to climb the hill. Sometimes you're going down the hill. Coming back, you up the hill. Coming back, you down until you reach Cameron Highland. This one maybe you are from, we call it Perak. We call it Batu Gajah. Right? So when you climb it and you're going down, this part we call it vertical curve. This one is horizontal curve. This one is a vertical curve where we are climb up the hill and going down. So we need the curve to make sure that our car is not jumping or flying. That's why engineer must locate all the survey points to make sure your vertical curve and your horizontal curve is really smooth. That's why we have calculation. So engineer must understand and must practice. Alright, and coming back to here. Number two, able to recognize geometrical of horizontal curve. So you recognize the shapes. You remember that. Remember back this line. This one is we call it horizontal curve. You remember the shape. And after this, you remember about the calculations and maybe some of terminology that describe about the curve. Number three, able to calculate setting out road curve using pre-computational data. So we are getting, we call it the data and how we want to set up. We call it all the survey data on field, right? So the introductions, so introduction about the curve. Number one, the design of curve stage and setting out of the curve is a very important aspect of an engineering works. Is important aspect. This is our part. Even though we have surveyor, you must check the data, you must check on ground the setting out before they lay the roads alignments. A road alignment mean that the center line, yeah,
Nabila dia terkeluar sini doktor.
it's okay. So when the center roads we call it we start from, for example, from Arrow Pradesh, okay, going to Alustar. So the center line of the road actually is our road alignment. It shows that our road alignment, our routes, okay, our directions, okay, that we call it road alignment. Number two, example in geometrical design of roadways. So the curve also we apply in roads. We also apply for railways. We all apply also for the pipeline for gas or oil. And all this required introduction of curve in design. I have one of my friends who work with now, I think, at Uni KL. So my friend involved with, we call it to design the railways alignment. You know that from KL Central, going to KLIA 1 and KLIA 2, you have one train under Berjaya Group, right? So that trains needs a tracks, or we call it railways. So the railways, you must do the survey to packs on grounds the alignments. So it might this include that the straight lines, the curve one, and the curve make sure that the railways, if reach 100 kilometer or 200 kilometer, when going and pass through this curve, that train or car cannot be overturned. Overturn means terbalik. Our car is collapsed because the speed and the curve must be have a special design because it's involved with the physical the physics law or the physics rules. Okay, right. So number three, initially all road design is usually based on a series of straight sections. So normally, of course, we need a straight line. Where straight line is a very fast. One straight lines, we save the times. We can see we call it the thing very clearly online, but there is only a theory. We need a curve to connect lines or the roads who not really straight, that we call it joined together. And when it's joined, we cannot simply join by straight line. We must put the curve. For example, like this. This is your road from from Penang to Ipoh. So from Ipoh to KL like this. You cannot say that your car going like this and going like this unless you have a traffic light. So to make it smooth because the highway, we build out a curve here. And because of this curve, it can make you faster and then save time, safety, and so on. The main problem is what is the radius? How big this radius? So that's why we want to learn from this lesson, okay? Because the radius and geometrical design determine the speed. If you want your train, the speed is going to maybe 300 kilometers per hour in future, or your car, you should speed up to 250 kilometers per hour in a highway. You must determine one part is the radius of the curve, because if the radius is not enough, you are passed through this horizontal curve or vertical curve, your car or your train will be overturned. Okay. In fact, it is impossible to accommodate this in design where position and location are affected based on the topography condition of the area. Sometimes, of course, we want a straight line, but due to, we call it the constraint of money, we cannot put so much money on embankment. We cannot put so much money, we call it to do field works. We fill up, maybe we call it 5 millions. So we try to do some, we call it orientation, horizontal and vertical curve, to make sure the road is not really expensive. We go for the economy, and number one, we still consider the safety. That's why your roads, normally normal roads, we put a sign. We put a sign to say that maybe this 1 kilometer per hour, and then we put this. We call it signboard here, 60 kilometer per hour, because we already determine the radius and geometrical design for the curve. So that's why we must obey the speed limits of the roads or train, or we call it a track of a train, right? In reality, every straight intersection must be connected by a lot of curve. That is normal for the highway. For example, that like this, we have like this, we go like this, we go like this. This is the road alignment, and then we construct the curve here, construct the curve here, the curve here, the curve here, the horizontal curve, this one, or you can also explain the vertical curve, alright? And this is the reality because we want save the money. Alright? A curve that intersect on a horizontal plane is called horizontal curve. I think you already call it, I showed to you about horizontal curve. Example, a turning curve to the left or the right of the roadside sections, and a curve that intersection on vertical plane is called as a vertical curve. Example, a road on a rising gradients or falling gradient in hilly area like this. You're going up and going down. So actually this one is straight line, right? So we alter this curve to make sure it's safe and your car cannot, or your car should be not flying or overturn at this point. Okay? So can you guess, is it a vertical curve or this one is horizontal curve? What is the answer? The answer, this one is the horizontal
Horizon.
Horizontal curve.
curve. That's good. So curve are basically classified as the horizontal or vertical curve. Horizontal curve is the horizontal plane and vertical curve is the vertical plane. For example, you have hill. Okay, so this is you alter your vertical curve. This is your car. You climb up actually and you're going down. Right? Okay, next. So horizontal curve, we have five of type of the horizontal curve. Simple circular curve. This A we are trying to teach you about how to set up the simple circular curve, because if you understand simple circular curve, it's very easy. It's easy for you to understand about the compound curve or combined curve, a reverse curve, transition curve, or we call it broken back curve. So in horizontal curve, we have five type of horizontal curve. Next, we have a simple curve. It's very good. So a simple curve is a curve intersecting 2 points. What is 2 point? T1 and T2. Two intersecting straights, okay. T1I, this one, T1I, and this line T2I, this line, this one and this one. Alright? And having constant radius all through curve line. So we have a radius maybe 600 millimeter, 600 meter, and then there is the same radius at 3 point, and this radius form the curvature of the curve. It is tangential to the straight at joining end. Is a tangential. Tangential means that we touch this point, we touch this point. So this call it tangential. Right. Next, in figure beside, T1T or TT2 is simple circular curve of radius R. So you have curve here. You have the, we call it radius, one radius only. Joining the two straight TI1, TI1 and T21. So at point I, intersection point, this one I. Alright? We go for the compound curve. You can see what different. Number one is the radius. We have two radius. Okay, there is, and then this radius, different radius at different center. So you mean that radius number 2 is bigger than radius number 1. So normally this one is, we have two existing roads that this road we want to connect. Okay, so because of last time this road is not designed properly, maybe we call it the old urban plan. So we are trying to do some maintenance to make sure the roads become safe. So we must have this one because this existing road we already have last time. So we just want to set up this curvature. But because of the obstacles, sometimes of building, sometimes of manhole, so we must have two radius. Okay, sometimes maybe the signboard here, so we cannot avoid. Okay, We cannot avoid something like the signboard is okay, something like utilities, telecommunications cable, electrical cables, or we call it water supply. So we must have two radius. There is, we call it compass curve, is normally for the maintenance works. Maintenance works and small radius. Is small radius. Two or more simple curve that is joined together. One, two, right? A curve have different radi, R1, R2. Alignment of curve that is turning is in the same direction, alright? Alignment mean that this line, you're going to this, okay? Or we're going from T2 to T1, or T1 to T2, okay? Whatever purpose is based on your side problem. It is joined with two intersection straits T1I, T1I, and T2I, straight lines. Of course, we have deflection angle here. Okay. In figure beside, T1I, T2 is a compound curve. Okay, this one is a compound curve. Right? With two simple circular, 1 and 2 radius. Okay. And then line ATB is a common target. ATB. We call it is a common tangent. And T is the common points. We call it this one normally the points where R1, R2 join. R1 and R2 radius join or meet. There is, we call it the point here, T. Okay, there is the type of, we call it a compound curve. First we have simple curve, then compound curve. Now we have another one, more challenging, a reverse curve. Reverse curve actually like this. We go from T1, our car, and then straight away to T2. We have, we call it radius 1 and radius 2, but this one is opposite. Is opposite. Opposite direction, Alright, opposite. Okay. Similar with a combined curve, similar, two radius connected at point T, right? Okay, let me erase first this one. Okay, right. We are going to draw again, right? So it's same, okay? But if the direction of curve are opposite of each other, we understand that this direction and this direction is opposite. In figure beside, T1T and T2T, this one, T1T and T and T2 is a reverse curve. It's a reverse curve. So like this and like this. We call it reverse. Formed from the curve T1TV, T1T and V, and we have another one T2TU, T2T and U, right? Of radius 1 and radius 2. Sometimes the radius same, sometimes the radius is different. That's one also normally apply for the maintenance works, or the space that very limited. The space is limited. That's why we use a reverse curve. And it's suitable to use in a common in railway system, and also we must apply in railway system some of part of that. And then this one normally we try in railway system or the road, we change direction. We change the directions. Normally we are going to left, now we are going to right, or we are going to from right, we are going to left. Okay. Okay, unsuitable for modern high-speed highway. This one is not the high-speed highway. This one is just, we call it, maybe the road system also is near the stations, or we call it, it's not going, you're going to take around 140 kilometer per hour for train or roads that we're using the reverse curve. If you go like this, I think your car or your train will be collapsed. All right. And lastly, D is also known as the serpentine curve or S curve because the S shape. So you can see that this one is S shape. Alphabet S, S. Okay, S like this. So normally it's not like when you mirror up like this. Okay. Okay, next we have transition curve number 4. So still in the horizontal curve, right? Okay, you can see this one. Okay, what is it? So you can see that we call it T1, T, D, D1, T5, T2. So you can see that transition curve in the red color here, and this transition curve from T1 to D and D prime and T2 is same, right? But this one we call it a transitions. And if you look out, so we call it very clearly. Look at very clearly. Okay, all right. And we have another one. We call it circular curve. Okay, we have a circular curve. This circular curve, all right? This circular curve, maybe the points going to this. This point maybe going to this. But we are not going to this. We alter this part, D to T1 and D prime to T2. We call it transition curve. So, transition curve, they combine with circular curve. This is for the special case. Sometimes we call it for road repair, or we call it to modify the existing roads, or maybe sometimes this one you cannot go for the high speeds purposes. Okay, so we'll get the point. So how many radius actually we have? Actually two. One is we call it a transition curve R first. Same this one also we have R1 is same. Another one is circular curve radius. R for the circular curve. R for the circular arc or circular curve. Alright. So actually we have one same radius and two. So we have two types of the radius. Okay, it's a curve usually introduced between a simple circular curve and straight, or between two simple circular curves, and is also known as the Eisenman curve. Eisenman curve that you want to make sure your curve is very safe and makes your curve is easy to the driver. And for transition curve, a transition has a radius gradually changing from finite to infinite value or vice versa. So the transition curve and simple circular curve we combine in this, we call it transition curve. So between sandwich, we have left and right transition curve, but on center we have simple circular curve. We combine it, this one, to fix it for the purpose of the safety of the highway, roads or railways. And normally is involved with, we call it maintenance works, or we try to adjust some, we call it spacings that is very limited on ground to make a horizontal curve. So we're using a transition curve. And it's widely used on the highway and railways since the radius increase or decreases is a very gradual manner. Okay, this is one object. One is we call it the advantage of transition curve. In figure beside T1, D1, you have T1, and then you have T, you have D. is the transition curve introduced between the simple circular curve like this, D1, and then you're going to T2. Okay, and the straight T1I, T1I, and T2I. Okay, so we have two radius for the transition curve. Next, the last one, we have a broken back curve. So what you can answer this one? From the diagram, you have two radius. And we connect with one tangent line. This one may be a straight line. A straight road, eh? Straight road. Okay? So we have two parts. One is the curve with the radius 1. One is the curve with radius number 2. We connect with a straight line. We call it tangent. And in the past, sometimes two circular curves having the center on the same side and connected with short tangent length are used for railroad traffic. Okay. Number two, since D is not suitable for high speed, they are not used nowadays. So actually, broken back curve, no more practicing today. Okay, so we can ignore this one, but this one is a theory. Okay, right. So now we are going about detail about element of simple circular curve. So what do you understand by this diagram? So this diagram is actually trying to show to you about something that's we call it a tangent length. Still remember this one, tangent length. Okay, it's something like we call it a deflection angle. If you look this one, and an angle of intersection. All right, and then you still remember T1 is our point of curve, and T2 is a point of our tangent. So this road start from A and finish at point B. Right? And this simple circular curve connected by radius R, and this radius start from the center of radius, we call it O, and this O going to T1, and this we call it O going to point T2, and they have, we call it a radius. Sometimes the radius is 300 meter, 900 meter, 1200 meter. The more bigger of your curvature, the radius becomes short. So your road have a high accelerations. Okay, right. So here you must understand about, we call it a tangent length. A tangent length is start from T1 to I here. To I. This one is I. Right? So, and then deflection angle, you see that this one is A going to I going to B, and then we connect T1 to T2, we have some triangulation here. So we have triangle over there. And from this triangle, you can see that if we are project from A1 to I, we are project over, we can have, we call it this angle. This angle based on IB to the T1I. So we call this one is deflection angle. Okay, and of course you also know this angle, half. Normally we call it, we can calculate by 360 degree minus the two deflection angle. Okay, you get the value, and then you divide it by 2. So you get this angle and this angle of intersection. Alright, and of course if you draw straight line from T1 to T2, you can have a center point here, we call it mid-ordinate, and we also can identify the technical over here. So then you can get point D. So you get point D. Okay. So, and then T2 and T1, T2 and T1 is a point of tangent, is a point of tangent. Or sometimes we call it a point of curve. So from this, we call it a simple circular curve. We understand that this curve from A to B. Alright, so the idea is like this. Let me we call it, erase this one. The idea is like this. We call it our existing alignment. What is our existing element? We call it existing, we call it road. So what is your existing? You are from A going to I going to B. Nowadays, because we have equipment of survey, you make it short. You put a curve here, horizontal curve. So you short of time, you cut, we call it your wastage. You cut your petrol oil because this is route number one. You're going over there, you're going to this, and you're going to this. But your point is you are going to point T1 to point T2. How about you, we call it shortcut like this? More safe, more we call it your money. You save your money, you save your time and so on. So that's why we choose this one. That's why the curve we build up everywhere on, we call it the world of construction for the whole world. We have always design and construct a curve. Okay, all right. So this is we call it the what we call it the terminology. This one, all the terminologies, and this one to make sure that you understand. If you don't understand, it's okay. After this, we have exercise. You know what is we call it tangent length. After this, what is tangent length from the deflection angle? How from deflection angle you can identify the angle of intersections? What we call it mid ordinate. How the radius of curve influence the safety of roads and so on. Because we have example calculation after this. Okay, next. Already interpret this one. Next, we are going for point. So point I is called point of intersection, this one. This is a point of intersection is really important because if you don't have point A, I and B, this simple circular curve is not happen. So actually intersection point, point I is the point where we meet up line AI and BI. In the same angle, same direction is something like you reflect angle A to I, you reflect back to A to B, right? So you can see that deflection angle. Deflection angle is formed in this point, at this point. So this deflection point is the intersections you are extended from A to I and B to I, you extend. So you can see that the deflection angle. And deflection angle, the value is really important because after this, we want to put it in the formula how we want to calculate and arrange the pack to form a simple circular curve on ground. Okay, we go next. Angle AIB. What is A? What is I? What is B? So what is the angle here? So this angle, okay, your theta angle is called the angle of intersections, right? Okay, next. So the sum of your theta and sum of your angle at central angle here, this angle, you plus this your angle theta or angle of intersections. It should be 180 degree. This one is another mathematical proven based on geometrical design where the angle of center plus with the angle of intersection, the value is 180 degree because this one is simple circular curve. So normally they found out this formula after they do it graphical like this. They draw like this, graphical. Okay, point T1. Where is point T1? Here, point T1. Tangent, point of curve or point of tangents. Point of T1 is the beginning point of curve and known as point of curve. So we start from T1 and then finish at point T2. And the point T2 is the last point of curve and known as point of tangency. PT. So we have PC, point of curve, and finish at point of tangency. We call it PT. Okay, I think you already we call it understand about element of simple circular curve. All right. Okay, next. We call it look down about again about element of simple circular curve. All right. So we have here we call it IT1. So where is IT? So I here to T1, okay, and I to T2, I to T2 at point of tangency. This one point of curve start one, right? Okay, IT1 and IT2 are known as tangent line and always equal in length. So tangent line is like this. You project here, you project here. This one is your tangent line. You project here straightly 90 degree. So this one also a tangent line. Okay, this tangent line in simple circular curve is always equal. Okay, so length T1 CT2. Okay, T1 and then point C. Point C is the center of curve on curve. Okay, and C to T2. C to T2. Okay, is called as total length of curve. Then normally we are finding the T1, C and T2, okay, because we want to know about the distance in kilometer of road after the road finish. So we must calculate the distance T1 to C, C to T2 to know exactly what is your curve road line. Normally, after the road finish, we call it in kilometer. But during the construction, we using the chainage system. All the measurement in meter, 40,000 meter during the construction stage. If finished, we call it in kilometer. Look at for the highway. So we have 34 kilometer from Taiping. So we have that one, kilometer. Okay, what is a point C? Point C is in the middle of the curve and can be labeled of summit or apex. All right. So we are going to erase this one. Okay, we go for this one. All right. So is C is we call it this one. Is we call it the center of the curve. All right. So then sometimes we call it as a apex or summit, even though this one is the horizontal curve. All right. But on graphical, this one is something like crown. It's a top on the top one. Okay. The chord join the point of curve and the point of tangency is known as long chord. T1 to T2. This one. T1 to T2 and pass through D. So we call this one is a alright joining chord. Chord joining. Okay. The chord joining of the point curve and the point of tangency is known as long chord T1 T2. Alright, so the formula is 2r sine theta over 2. 2 radius for say the 600, sine is sine. Your deflection, your angle of intersection, this one, angle of intersection. Okay, it's the same, take from this one. Alright. Okay, and divided by 2. So there is the correlations between the chord joining T1D and B here. Alright, distance between points I, this one point I, okay, and apex point C. So we have distance here, we project here. So we have distance here, okay. Distance between point I and apex C is called the apex distance. So we call it this one, the distance is the apex distance. Apex means that something like on top. Something that is really important. Okay, angle T1, so angle T1, angle O, where is O, and angle T2. This one, okay. Subtended at the center of the curvature 0 is known as central angle. This one, central angle. The central angle is equal to deflection angle. This central angle same with the deflection angle. So again, a mathematical correlation. Deflection angle and central angle is same in simple circular curve, or we call it horizontal curve. Okay, next we have designations. Alright, so you look at this one. We have at point T1, and then we have certain angle, D degree, maybe 30 degree for example. Okay, 30 degree. So this 30 degree will open up at for the 30 to 20 meter. So we develop D angle, okay, from 0, and of course we have radius here. Then we can see that this one the length of curve. So if you want to measure the distance from T1 to the center, okay, the center point is one, or we call it apex. So the distance is maybe 30 to 20 meter. So you can calculate, we call it this one, and this one will to show you about arc definition. Of course, we call it a curve, but this curve is a very line. So to make it, we call it the curve is very line. So now we cut it for the small arcs, and this small arc form the curve. That is how the story about arc definition. Or, and if we can say that chord definition, don't worry, after this we can calculate about chord definitions. It's something like this. You start from T1, you go to the center, maybe this one is point D. Then what you do, you will call it connect T1 to point D. Alright? And then you do, we call it some measurement like this. So you can have chord length mean that a straight line. This one straight line from point here T1 to point D on the straight line. So we call it chord definition. If you follow the circular, if curve 1, the distance, so we call it arc definition. But if you want to measure the curve length, this is the right method. Okay? Sometimes we're using a chord definitions to circle out the curve of root. Okay. You can see this one is follow the curve. This one just a straight line. So this one we call it chord definition. This one we call it arc definition. Right? A simple circular curve can be designated by radius method or by degree of the curve method. We already discussed. The degree of curve D can be formed by referring to an arc of curve and chord of curve. This one. Chord and arc. According to arc definition, this one, arc definition, the degree of a curve is wait, let me erase first. Okay, the degree of curve, all right, or we call it D, can be formed by referring to an arc of curve or a chord of curve. This one arc, this one chord, this one arc, chord. According to arc definition, the degree of a curve is defined according to the central angle from by an arc length. Meanwhile, according to the chord length definition, the degree of curve is defined according to the central angle subtended by a chord length. Okay, in highways, it is customary to use the arc definitions, whereas the chord definition is utilized in railways. Okay, for highway, normally we calculate, we call it arc definitions for this one. And for railways, utilizes with the chord definition. This one is for train, this one for your car. Okay? Alright, that is the designation. We go to slide number 15 about how we want to calculate about the arc definitions. Okay, but don't worry, because after this we have exercise, so you can see we call it how to calculate the chord lengths, what is the radius, in fact the chord length and so on. Okay, now relation between degree and radius of curve. So arc definition. If R is the radius of a curve, okay, R is the radius of curve. Still remember R? Yeah. Of curve, and D is the degree for the 30-meter arc. So this one is D is the angle for the 30-meter or 20-meter arcs. Then, so there is the formula relationship with this one. This statement like this statement going to this. R time D, radius time D, degree is for the arc 30 meter, times by pi divided by 130 degree equal to 30. Equal to 30 meter of arc length. So when we are manipulating this formula, you can get this formula. So actually we arrange it. R is equal to 30 times 180 divided by D times pi, or if you want to calculate R, 1718.9 divided by D equal to 1719.D. So we make it shortcut, right? Okay, next. Relation between degree and radius of curve, right? So relation between degree and radius of curve. So is it same like this? Okay, another relationship. This one is based on 30 meter. Now it's based on 20 meter. Right? If the degree of the curve for the 20 meter arc, then R times D times by pi 1 divided by 130 degree equal to 20 meter. Okay, arc. Or R equal to 20 times by 180 degree divided by D times by pi, or we can arrange it R equal to 1145.9 divided by D and is equivalent to 1146 divided by D. This one we make it the small value going to the is quite we call it even number. Alright. So there is how relation between degree and radius of curve based on 20 meter and previously based on the 30 meter. So you can see that this is the formula 1718.9 divided by D. Meanwhile here is 1145.9 divided by D. Okay, slide number 17. Relationship between degree and a radius of curve R3. Relationship between degree and radius of curve 3. Chord. For example, the chord is 30 meter length from triangle T1OM definitions. T1O, we have M here. So this one, the angle is D degree divided by 2. Okay. So for 30 meter chord from triangle T1 O and M definition, sine D over 2, D is we call it certain angle for the 30 meter. When the 30 meter is length of chord, so what is D? We want to search for D. So sine D over 2 equal to T1M divided by OT1 equal to 15 per R, or your radius. So your R, you arrange back like this. So your R is equal to, let me erase this one so it's very easy for you to we call it understand. So let's continue. So R equal to 50 divided by sine in bracket D over 2, or since D is very small, therefore sine D divided by 2 is equivalent to D over 2. Hence, the radius of equal to 15 or divided by D over 2 times pi 180 degree, or the radius is 115 times 2 times 180 divided by D times pi, or R 1718.9 divided by D, or 1719 divided by D. So this is relationship between degree and radius of curve. Okay, next we go this one, relationship between degree and radius of curve. This one is for 20 meter. So since D over 2, remember that we want to find out D angle, what is the value, because we don't know. Okay, D over 2 is equal to T1M divided by OT1. We divided. Okay, is equal to 10 per radius, or we change to this formation of formula R equal to 10 divided by since D over 2. Since D is very small, therefore D divided 2 is equivalent to D over 2. Hence, our radius R is equal to 10 divided by D over 2 times by pi divided by 180 degree. And then on top of that, we have 10 over D over 2 times pi divided by 180 degree. So we get the value, or we change this one to this one, this formula. R equal to 10 times by 2 times by 180 degree divided by D time pi. Okay, and if you change the formula is R is equal to 17114.9 divided by T by D, or you change it is we call it very near value, we call it 1146 over D. So next what we have is a formula for element of simple circular curve. I think I already told you about the point of curve and so on. Apex distance, already told you this one. You can skip this one. We go for slide 20. Alright. Okay. Formula for element of simple circular curve. This is the relationship. How we call it the length of curve. And then how we want to calculate based on the formula, because this formulation we take because we have this graphical. Because of this graphic, so we can measure angle and we can measure distance, and we can search for the mathematical relationships. Okay, and you can see this one, the mathematical relationship for the curve is a formula for element of a simple circular curve. So what the meaning of length of curve? So length of curve, you still remember, we have this triangulation. This one we have R. This one, length of curve. This one. Okay, this is horizontal curve. This one. This curve, length of curve. From this one to this one. So we call it length of curve, LC. Alright. Let the length of curvature T1, C T2, BI, and let R be its radius. So we try to change. Okay, what is the scenario? Then IL equal to R theta equal to R theta pi divided 1 divided with 180 degree, where your deflection is decreases if 30 meter arc or chord definition is used. Then L I equal to 1719 divided by T by D times by your angle, theta angle, times by pi divided 180 degree equal to 30 angle divided by D. And if 20 meter arc of chord definition is used, then L equal to 1146 divided by D times pi 100 per 180 degree equal to 20 your deflection angle divided by D. Okay, there is relationship formula for element of simple circular curve. It's something like complicated. After this, you start to apply, you understand, and it's very easy for you to score in your test. Okay, formula for the element of simple circular curve, T, tangent length. Tangent length, where is it? T1 to I to T2, or T2 to I to T1. So we have two tangent length over there. Right, so how? T is equal to, tangent length is equal to I T1 equal to IT2, so equal to R radius, relationship this one is R radius, time by tangent, time by deflection angle, divided by 2. That is formula for the tangent length. So you can say that tangent length equal to R X tangent, okay, deflection angle or theta over 2. That is the formula for the tangent length. And focus along chord length. So long chord length. So how you want to calculate for long chord length? So this one, long chord length. L, long chord length, equal to T1 dt2 equal to T1. Where is your T1? T1. Okay, it's going to D, this point. And going to T2. Straight line like this. Okay, equal to 2 T1 times D equal to 2 tangent length. Okay, 2 tangent lengths. Alright. Okay, times by D. Times by D. This D. Okay. From triangle, OT1 times D. From triangle, you can see that OT1D. Let me scrap first. We erase this one first. Okay, sounds good. This look good. Alright. From triangle OTD1. O here T1 going to D, this angle. Okay. Since theta over 2, this one theta over 2, right, is equal to T1D. T1 going to D. T1 going to D. Okay. Or R or T1 times D. T1 times D equal to R sine theta over T over 2. Hence, for the long chord, this is formulation 2R sine theta divided by 2. This is the formulations that for the long chord in horizontal angle, simple circular angle for this topic. So now we have example. Alright, so now we have example. Alright, two tangent intersect at channel 1250 meter. For example, that you have here is a point, something like is from Alustar. Maybe start from 0. And then you go to this line until we call it I intersection point. The channel is 1250. And then 1251, 1252, 1253 until you reach this one T1, until you reach this one T2. Normally distance is same. For example, this one tangent length is equal to 10 meter. Here also tangent length is equal to 10 meter. Okay, so two intersection intersect at channel 1250 meter. Again, I tell you that channel mean the length of road during construction is considered in meter. So when start the road finish, so we say like this, 1.25 kilometer from Alustar to Ipoh. This is, we call it under construction, this one. So the value meter. In kilometer, the road supervised by the kilometer lengths. That's finished. So the length of the roads we consider in kilometer. So the angle of intersection is 150 degree, this intersection. If this one 150 degree, you can see that relationship like this. This one also 150 degree. This one, if this one 150, this one is 150. So mean that 150 is the plus with 150. So you get 300, right? So one circle complete, we know that 360 degree, right? We minus with 300 existing one. So we get 60 degree. 60 degree is the deflection angle, this and this. Do you understand me? All right. Okay. Radius of curve is 250 meter. Okay, I go to erase. Also want to make sure you understand a little bit. So please be patient. It's quite boring in the calculation, but it's okay after this because we have examples, we have some exercise to do, and then you understand what I try to explain to you about this terminology, the mathematical relationship, and so on. Okay, when come to the practical, it's become easy. But come, we call it when you are studying, during you study, is quite boring. Excuse me, right? So next, we say that radius, radius. So where is your radius? D is the radius. Curvature. This one is the radius. Alright, this one is radius R. So the radius is stated 250 in meter. Right? Calculate all data necessary for setting up curve. Type interval is 20 meter. They want to tax at 20 meter here, 20 meter here, 20 meter here, 20 meter on ground, right? And then they connect with a string, and then they will add new roads, new curve. So this is, we call it example of calculation for simple circular curve. Okay, solutions. How we call it, we want to calculate about deflection angle. I think I already show you that we get 30 degree. This is another way we call it, your deflection angle is 180 degree. So you minus with 150 degree is equal to 30 degree. So you still remember that this one is an intersection point, I told you. Alright, and we have here is the angle is 180 degree. Same like this, we have 180 degree. Okay, if we know this one is 150, so 180 minus 150, so you get 30 degree because this one 150, this one is 30. So if you plus this to 1, you can get 180 because it's in the one straight line, 180 degree. For example, also like this, here also 180 degree. When you combine 100 plus 80 degree plus 180 degree, you get 360 degree. Is one circle. Is one circle, and this is the center point. Alright. Five mandatory items to calculate. You must calculate this case tangent length, length of curve, change for first point, change for the last point, and lastly your deflections. So you calculate about the tangent length. We have already have formula radius. So your radius, you times by tangents, and then you times by your deflection angle. You divide it by 2. Your radius is 250. Your tangent is constant, so your deflection angle, you get this one, the value here. So you divide it by 2. This one is the formulation. You cannot change. So you get 67 meter. So what is mean that the 67 meter? Okay, let me scrap this one. I wrap first. Wait a minute. You know about 30 degree, okay. So our question now, where is what the meaning of 67 meter? Still remember this arc? Okay, this one your deflection angle, this one your curve, this one your radius, and so on. Okay, tangent length is length here, from here to here, from here to here. Okay, this one normally we make it T1, this one make it T2. So what is the length of the tangent length? What is the length for the tangent length? So tangent length, so this formula you can get 67 meters. So from here to here, the answer is 67 meter. Alright? So now we calculate about length of curve. Where is the length of curve? Here, length of curve. So I show you by drawing, but I put it in different color. I put different color. Maybe this one is like this blue color, right? So the what we have now, uh, length of curve, length of curve here. So we must calculate. They have a simple formula. So the formula is pi time by r. Your r remembers at 250. Your deflection angle 30. Your r radius is 250, right? And then time by your deflection angle, okay, 30 divided by 180 degree. So when we calculate pi time by 250 times 30 degree divided by 180 degree. So you get for the length of curve 100 130.89 meter. Mean that this length is like this. So we calculate from here and here. So based on the, we call it, is not the chord one, is we call it follow the curvature. So 130.89 meter is length of curve, alright? And we already calculate about the tangent length, 67 meter here, right? And then we also calculate about the tangent length. Now we have length of curve. We know that how to calculate about deflection angle, how you get 30 degree is not 150 degree, right? Okay, so next we go number 3. Change first point, how we want to calculate. So do you understand this one? Okay, let me erase this one first. We erase, huh? We erase. We erase. Okay. So change for the first point. Let me draw back again about your curve. So we have point I. We call it this one. We have your radius. You have, we call it curvature curve. Okay. And then you have, we still remember a deflection angle. Deflection angle is 30 degree. Your tangent length here is around 67 meter. Okay, and you still remember that your, we call it the change at point I here. The change at point I here, like this. So the change here is look at the question is around 1250 meter. So the change at point I. Okay, so if you want to know the change at point this one, so how you calculate is very easy. 1250 meter, we call it the change at point I here. You minus by 67, you can get this one. So here the example. So 1250 change at point I here, divided by minus y tangent line 67. So you get 1183 meter here. So your change at point T1 is equal to 1183 meter. How we want to search for the T2 here? So T2 here, the calculation is easy. So you get this point. So 1250 meter, you plus with 67 tangent line, because this one also 67. This one also 67. So you plus with 67. So when you plus this one, you get 7. Then you get 11. We have 3, we have 1. So the at point T2, the change is this one. Okay, 1317 meter. Right? So point this one. Okay, now we go the change change last point. Okay, you also can get 1183 meter. You plus with this one. Mean that from here, you can get the value is what the value is here. First point, 1183, 1183. You plus with this curvature side, this curvature line. So 130189, this value. So you plus with 1, 130.89. So you get this length. You get this length. So you get this length. So you get this point. The point is like this. The challenge here is 1313.89, or this challenge is like this, 1317. Okay, because we have this one is a method number 1, this one is method number 2. How we can calculate the change point at point T2? We have two methods. And for deflection angle, so deflection angle, after we want to set up this one like this. All right. Deflection angle is something like this. We want to do a setting like this point, right? Pack 1, pack 2, pack 3, pack 4, pack 5, pack 6. You mean that you put your pack. Still remember that the pack you use in front of Pusat Islam Field. So we have the pack. So here also we have shoot pack. So every pack here, we must have, we call it this one 0. What is the angle here? What is the angle here? Based on this one is 0 degree, 0 minute, 0 second. So what is your deflection angle for every pack? Because it is our control point. This one is our control point. Don't worry, after this, we call it exercise. So when you get this one, this is the conclusion. We have 8 point I change 1250. We have changed at T1 1183 because 1250 minus tangent length. So you get this one 1250 plus with tangent length, you get this one. Or to get this one is change 1183 plus with chord length, plus with curve length. So you get 1313.89 meter. Okay. Right. So in your calculations, we must put a standard chord length where we have a standard distance. A standard distance. So you can see that this one, chord length from this one to this one, same length. But for the initial and final chord is different because sometimes we cannot make it equal, right? We cannot make it equal. So we must adjust our initial chord and final chord, and the intermediate chord, normally the deflection angle is same, the tangent length of the chord also same. L equal same or equal the rest two, final chord and initial chord, is not the same one. Alright, that is how we set up. Normally, this is the ideology. The initial and the final is the different value if compare it to the standard value in the intermediate. Of course, we want to do like a standard length, a standard angle, so we cannot headache. But normally on site, this is the experience, what people say, the experience will tell you, saying that initial and final chord is different. We have another 1, 2, 3, 4 slide. Okay, solutions. Okay. So number 1, to calculate initial chord length and final chord length. Initial and final. What is initial? This one initial. Where is final chord? And then this one, we calculate one, we can know the rest. So this one is a unique and separately different calculation. So length of initial chord for the first one, initial, this one, okay, length of initial chord, first point to mark on curve. So we mark on curve, and then we take JNH 1190 is chosen as the first point to pack out. Okay, if you know this one, so 1190 minus JNH tangent point equal to 1190. So is JNH at tangent point 1183, so equal to 7 meter. Alright, so because for the first we get the value is 1190 and above, so we must go for the even number, right? So we get this one. So you know this one is an initial chord, and then a full chord, final chord. So the 7 meter value is from this one and this one. Initial chord to the first, first we call it, this one is what meter? 20 meter. The first 20 meter. Okay. Alright. So we have this one, and then we calculate the final chord because this is different. So we get now the first point to mark on curve for the length of initial chord is around 7 meter. Right here. Then we have 7 meter, and then we calculate 7 meter, we plus this one. We set up 6 points in intermediate, and each point is 20 meter. So you get 120 meter. 120 meter, we plus with 7 meter, and we minus with the curve length, the overall one, the here. So you get this one, the last chord. So the last chord is 3.89 meter. Okay. Total of chord at every 20 meter interval equal to curve length divided by pack interval. So you get 130.89 divided by 20. So you get 6.5 chords. So take 6 chords. Okay, we just 6 chords. JNH cover until 1190 plus 6 times 20 plus 6 times by 20. So 20 is mean every pack is 20 meter. The initials and the last one is not same because we adjust. So length of final chord 1313.89 minus 1310, so equal to 3.89 meter. This means that length of final chord, this one. Okay, all right. So next slide 28. How we want to calculate the deflection angle for the first point, for the initial one? How we want to calculate? So we're using the formula 1718.9 times by L divided by 60R equal to 1789 times 7 times 60 radius times 250 equal to 0 degree 48 minute 8 second. So reflection angle for full chord, we have a 6 number right here. Okay, so 1718.9 is the formula is same. Time by L divided by 60R equal to 1718.9 times 20 divided by 60 times 250. So you get 2 degree 70 minute 31 second for the second point. And then for the third point, and then fourth, fifth until 6th point, we finish this one. And deflection angle for finals is very easy. This is the same formula. So is equal to 1718.9 times 3.89 divided by 60 times 250 is equal to 0 degree 26 minute 45 second. Okay, and let the explanations. Deflection angle for first chord is 0 degree 48 minute 8 second. This one, this angle, how I want to recall it, draw this angle, this small angle, this angle, so is 0 degree 48 minute 8 second. Alright. Deflection angle number 2, from here to this point, from here to this point, from here to this point. So every this one is 3 degree. Second one, this one first, second, 3 degree 5 minute 39 second here. Number 2. This one number 1. And lastly, number 3. So number 3 they calculate. So they get 5 degree 23 minute 10 second. Alright, so checking. So you put all your first angle, intermediate plus the final equal to your deflection angle divided by 2 equal to 30 degree divided by 2 equal to 50 degree. So 50 degree is center angle for the 30 degree divided by 2. Center angle, here this one. Right? Okay. And we put everything in table and we finish our class today. And still remember that you can see that this one we start with 0 angle, and this is our first, second, and number third one, fourth, fifth, sixth, seventh, and then the last angle. This one is the last angle. Then we have we call it our last angle. And there is the important is this calculation. And this one is same. 1, pack number 2, pack number 3, 4, 5, 6, 7. And then this one is the last one. Okay, T2, and this one T1. The first one you calculate. Alright? So how you get a total of this one? Let me erase for you. So because of pack number 1, we don't start back again, but we put in table. We never start again. So still 1183, 0 chord length. We don't start first. We call it the value first. Then we start with a 7 meter, and then deflection angle 0 degree 48 80 second. This is total angle, and then there is the angle to be set up on ground. You can see this one is 20 second. This one 8 second. So when you go to 8 second, you must read 20 second because our theodolite is moved every 20 second or every 40 second. So what we have in lab, we have 20 second theodolite. That's why when come to 0 to 19, we set to 20. But when come to 21 until 39, we set as a 40 degree. 40 seconds, sorry, 40 seconds. Right? So here we set 20 seconds. Next, the chord length is 7. Next is 20. We calculate the deflection angle is 2 degrees 70 minutes 31 seconds. So the total number of angle, this angle, you plus with this angle. So you get this angle. Alright? So this angle, you get this one. Angle to be set 3 degrees 5 minutes 39 seconds. Because 39, so we set 40. So you can see this one, all calculation like this. This one is total angle, and this one is theory part, and this one on site part. This one is on site. Okay, until you finish and you set angle is 50 degree. 0 minutes 0 second. That's all from me. Hopefully we can finish this one. And then if you do we call it calculation from the chord length view, so you can get 67 meter, and the chord length we are measured. You still remember that the chord length like this? This is a chord length because this one T1 and T2. So must be same 67. If you calculate 69 meter, totally wrong because you already calculate 67. So angle of deflection also you can calculate for total. It should be plus or this one is 50 degree. If you get 30 degree, mean that your data is wrong. Okay, and this 50 degree must be same here. Angle to be set must be same. If not, it's wrong. For example, this one 50, this one's 50 degree, 30 minute. That is wrong. Okay, all right. So by that, I think I finish my class today. For the curve, hopefully you still we call it with me now.
Of
So
course,
thank you
sir.
everybody.
Doktor
Yes,
tahu
doktor.
kata, saya rasa kan saya kena tengok balik